Hello guys, how are you? This is June. Today we're gonna talk about exercise 5. Some of you guys asked me question on exercise 5, and so I thought I should give you some more hints on that. Uh, Slide 5, the binomial distribution part is actually a little more mathematic involved than any other chapters. So always remember the formulas for the binomial distribution, which is basically probability of x equal x is basically number of sample size and x and probability the power of x and 1 minus p to the n minus x. I mean, it's good to memorize this formula, but if not, you can look up in your slide, etc. Because in exam, it's gonna be open book exam, so you're allowed to look at this one. So let's look at first question. I'm gonna share my screen. Give me a second. Okay. So the first question is, okay, let's X be the number of headset functioning well. What are the parameters? So read the question carefully first. So a call center hires 10 core agents and owns 11 headsets. You know, they are hiring 10, but they have 11, right? And but the headset are too old that they are not functioning well with a probability of 0.5. So the binomial distribution is always like that. It's gonna be when some x is like some, you know, say, I mean, this x and this x are a little bit different, but if x is something 1 or x equals 0, something like that, that kind of thing is binomial. So if x is 1, if, I mean, it depending on your preference, but you got to be careful about them because I mean, this x is a little bit different than that because in class slide, I said, you know, probability of y equals some number of whatever number x or something like that. So this x on the homework is corresponding to here. So in this homework, the x is actually the number between 0 to 11 because x can take any value between 0 and 11, but the x in the class slide was in a binomial variable. It's going to be the 1 or 0. So be careful because in class slide, so for comparison, it should be actually y, you know, instead of x. So if that make you less confusing, I will just use y. But it doesn't matter. Notation doesn't really matter here. But if, you know, whatever binomial variable. So binary variable is what? Binary variable is either 1 or 0, right? So 1 if it function well, or 0 otherwise, or the equal 1 if it doesn't function well, 0 if function well. Something like you should make a definition. But it can be anything. So for example, you should set a probability. So probability of x equal 1, you know, I mean, if x is just 1 or 0, then that is where x is headset. I mean, I can say x equal 1 if it's working okay, and it's not okay. Something like that. You can change it the other way. For example, I'm choosing whatever x. I mean, again, sorry about the notation because in class slide I use x equal 1 or 0, but in here I use x for this y, so then make you confusing. But in the exam or homework, as long as you use your definition and show me the definition, and then start from there, it doesn't make you confusing. So do not worry about the notation. Instead, make sure you understand what's going on behind everything. Okay. if probability of x equal 1 that is functioning okay equals something like a p, then what should it be this one? Then it should be actually 95%. And probability of x equals 0, which probability of headset not functioning well, it should be 5%. Why this is the case? So let me go back to the question again. So share my screen. Okay, it said problem said probability with a probability of 5%, it's like not functioning well. So that's why this is the case. I mean, normally in class slide or in here, for example, you could set probability of x equal 1 as 5%, or probability of x equals 0 is 1 minus of 5% as 95%. It's fine, but the thing is, here, the x equal 1, if it's okay, so I set the definition. As I discussed in class slide again, I mean, make sure you guys watch the video, okay? So I said the probability of x equal 1 or probability of the headset is okay, okay, equal 95%. But this x equal 1 is like a probability of, the headset is not working okay. So you got to set your definition. I mean, in either way, you'd get the exactly same answer, but the x equal 1 here is not equal x equal 1 here. So those are totally different. So I explained the differences, and I went over a lot of good examples in the lecture. So make sure you guys watch the video, okay? So given that, so I mean, I prefer to use this one, but you can use this one as well. Either way would give you the exactly same final answer. So the answer for the first question is like that, okay? So given this is the case, the parameter is like asking you, what is a p probability and what is the sample size. So that is actually the thing you're asked. So what is a p? Or let's go with the sample size. What is the sample size? How many headsets are available? There are 11, right? So n equal 11. So probability is a little different. If you are saying probability of a headset functioning well is p, then it should be 0.95. So you should say probability of headset okay x equal 1, or you can say or headset or headphone equal okay okay, or say or x equal 1. If this is your definition, then it should be 0.95. So otherwise, then p equal x 0 is 1 minus p, or 1 minus 0.95. So this is the case. I mean, if you are confusing, I went over similar and a lot of good questions in the class slides. So you might want to check it out, okay? So given that, I mean, I already gave you the answer. Answer for the first question would be, probability p equal 0.5 and n equal 11. So that was the parameter you are asking. And okay, let's go back to the second question. While you guys are looking at this slide, I'm gonna erase the board. Okay, the second one is like, okay, calculate the expected number of headsets. I mean, this is obviously too easy. Expected number is what? So we find the expected number. So expected number is basically asking you average. So, I mean, what is the average? Formula for the average? If you go back to the slide, I think 3, and again explained in slide 5, it's gonna be what? N times P. So N was what? 11. P was what? 0.95. So it's gonna be what? 1045. So that means, okay, on average, I expect the number of headset be 10.45. That is answer for B. I mean, I shouldn't give you this answer, but yeah, anyhow. Okay, the answer for C is calculate the probability that only one headset is not functioning well. So calculate the problem. So you got to first think about the question. So I'm asking probability that only one headset is not working right. That is, in other words, what? That is a probability of, you know, if X, I mean, I can use Y. I mean, I don't know why I use X. So Y equal 10. So basically, number of headset working well equal 10, right? So this is what you are looking for. So plug in the formula. Yeah, I mean, I'm not gonna go over the formula in detail. You can just plug in the number, right? So this is something, but that was if a probability of X equal 1 equal 0.95. I told you earlier, the answer would be same if probability of X equal 1 equal 0.05, where this X is the probability of not working well. Not working. This is what? Probability of working. Believe me, if this is the case, then you are looking for probability of Y equal 1, because you are looking for probability that Y, where the number of headset not working equal 1. This is where number of headset, this Y equal 10 is number of headsets working well. Number of working okay. This is number not working okay. Both give you exactly same answer. So both would give you exactly same answer. You can try. And the question D is calculate the probability that 10 headset or more are functioning well. So those are the probability. So that means, you know, I mean, you can think intuitively. So I will just erase this. So I'm asking, calculate that 10 or more headsets are working well. That is what? So if I say the P equal 0.95, where this is a probability of working well, then the answer would be then probability of X, no, actually probability of Y, number of headsets working well is, you know, greater than or equal 10. This is you're looking for. But if you're saying P equal 0.05, where probability of not working well, then it should be probability of Y less than or equal 1. Both give you exactly the same answer. Plug in all the numbers there, you know. I pretty much gave you all the answer. Only thing left is you just plug in the number, right? So part E was calculate the probability that there are not enough functioning headset. When do you not have enough functioning headset? Part E. Then, I mean, obviously, if Y is less than 10, or so that is basically probability of Y is less than 10, right? This is what you're looking for, right? So just get that. In other words, this is what? 1 minus probability of Y greater than equal 10, right? Because summation of probability equal always 1. But if we are saying Y is number of headset not working well, I'm showing you two cases. It doesn't matter which one you choose as a probability. Final answer will be the same. So, so if Y is number of headset not working well, then it should be what? It should be greater than 1, right? So you'll find the probability of Y greater than 1, where this probability is what? P equal 0.05. This is P equal 0.95. If you are confused, make sure you guys go back to the slide, okay? And actually, it's so easy. So I'm not gonna just go over. Just you guys just replace the number of sample size, okay? Good luck with this homework 5. I pretty much gave you the answer. Those who have submitted, you might want to revise your answer if your answer is wrong. Okay, also I posted a review slide and then a review video. Make sure you guys are looking at that, okay? I explained in detail how you approach your exams. Okay. Good luck with your exam. Talk to you later. Bye.